Hello guys, as usual we are trying to solve LeetCode problems and today question number is question number 121. So let's look at the question. Okay, so the question title is best time to buy and sell stock. So the topics for the question is array dynamic programming. You are given an array prices where prices I is the price of a given stock on the ith day. You want to maximize your profit by choosing a single day to buy one stock and choosing a different day in the future to sell the stock. Return the maximum profit you can achieve from this transaction. If you cannot achieve any profit, return zero. Price is 715364. Output 5. Buy on day 2, price equals to 1 and sell on day 5, price equals to 6, profit 6 minus 1 equals to 5. Note that buying on day 2 and selling on day 1 is not allowed. Okay, that's understandable. 764321. Okay, so I guess what we have to check is we have to go through the array in reverse order from higher index to lower index and check whether the no, the number here is greater than the number present in upper part of the upper part. Okay, so do we have to check every possible value? Yeah, I guess we have to. Let's look at, okay, so the price length will, can go from 1 to 10 to the power 5. That's bad. Mm, so if I try to do it in normal way, then I can get time complexity error. As if there are 10 to the power 5 possible days, then we have to, if we try to check for each day, then it will be 10 to the power 5 into 10 to the power 5. Okay, so let's try to think of an idea. Basically, what the question is saying is that we will give given an array where the price of stock in each day will be mentioned. Suppose the I will take random numbers 7, 3, 4, 1, 5, 1, 5, 2, and 8. Okay. So what we have to do is check in which day we should buy the stock and in which day we should sell the stock. As the stock which we buy in this day and sell in this day will have the maximum profit, so we will return this value. However, if we have a problem like this where the array is present in descending order like this, then we should return 0 as there will be no profit if we sell in, sorry, if we buy in first day and sell on third day, or if we buy in first day and sell on second day. What we could do is we could check every possible profit and compare each profit, and the highest profit could be returned. However, if all profit are in minus, or in another word, if all every return is less, then we can return 0. But as there are 10 to the power 5 possible ways, so I think doing that will result in getting time complexity error. So we have to think of another way. So what we could do is we could run through the array each time and check whether given element in ith index, where we are running the loop in reverse order, is greater than the element present in I minus nth element of the array, right? And if it is, but if we do like, then it will be mm, mm, I keep thought of an idea. Let's try to solve the question that way. And I equals to 0, I is less than prices dot size, I plus plus only row one plus I plus plus mm, it's what I was doing forward. Let's see again. Yeah, I was thinking let's make an integer named lowest which is currently storing 0. Sorry, let's make an double variable which is storing 9999. What's the maximum value? 10 to the power 4. So 10 to the power 4 equals to 10,000. So what we can that is 10,001. 10,001 and we require uh, the greatest variable storing 0. So what we can do is we will go through each loop. Okay, we will require other two variable which is lower, which is lowest index and greatest index. Okay, for doing this way, mm, okay, so basically instead of doing this, what we could do is the greatest equals to 0 and it would 5 minus 1 for in z equals to I plus 1 j is less than process dot size j plus plus. Now what we could do is let's make a variable name, sorry, temp, and what temp will do is temp will store the value of the stock or the value of difference in stock from z day to ith day prices j minus prices I, right? Actually, I wrote cost here. This should be minus. After doing this, we can check if temp is greater than, if temp is greater than greatest, then greatest should be replaced with temp. And after this loop finished, we can simply return. Okay, so let's try to try on this program. What I actually did is, suppose let us take an array 1, 2, 3. Okay, so we have two variable named temp and another one is named greatest, right? So when we try to go through loop each time, first I index will be 0 and j index will be 0 2. So sorry, it won't be 0, it will be 1 as we are using I plus 1. So I index is 0 and j index is 1. So we will subtract this in this, which becomes 1, right? So temporarily will hold 1, and the value of greatest at first is 0, and we are checking whether temp is greater than greatest. As temp is greater than greatest, so the value of greatest will be replaced by 1, right? Again, we'll, we'll go through this loop, and j index will be 2, and we'll compare these two and subtract, which will be equals to 2. So temp is currently holding 2. As 2 is greater than 1, so the value is replaced by, sorry, so the value will be replaced by 2, right? Again, index I will go to 1, and we'll compare 2 with 3. Sorry, we will differentiate 3 from 2. As j index will be 2, and the difference is 1, as 1 is smaller than 2. So this if condition will be false, and the value which is present inside of greatest variable will be returned. And as we know, the correct answer is 2, so our answer is correct. However, if this loop was present in reverse order, 3, 2, and 1, then what would have been, right? Um, each time when we differentiate this index with this and this, and also for this and this, all answer will be negative, which is less than 0, right? So the value which is present in the beginning of the program, which is greatest equals to 0, will be same in the end of the program, and the program will return 0. Let's try to run this program. I'm actually worried as the size, or sorry, the length of prizes is equals to 10 to the power 5. So we might run into issue, but I guess, yeah, we did. Time limit exceeded. That's what I thought would happen. But there are so many days, so we can possibly go through its index. Mm. So what I'm thinking is, instead of going through its value, we can go in linear path from first index to last index. What I mean to say is from 0 to n minus 1, and we can check whether the value present inside of any of these term is greater than the value present inside of 1, and if yes, then we will pick this value and we will try to subtract it from this value, right? And if this value is okay, so it won't work, I guess, doing that one, but at least we can try. For int I equals to 0, I is less than prices dot size I plus plus. We will go through each term linearly. Okay, so if we are going there, then we want 0, we can start from 1, and we can, instead of writing greatest, we can use double thing equals to prices 0. So we need to create an array. When creating an array, it will look, let's say, going through each one and differentiating. What could be the logic? Mm, okay, I guess I need to go, or I need to solve this problem using what I thought at first. We require we require a variable named greatest, which is currently storing 0, and we require a variable named lowest, which is currently storing 1001. And we also require other two variable, lower index and greater index. What I'm trying to do is trying to go through the loop in linear path, where we will check each value, and if we will try to find the greatest value, and we're trying to find the lowest value, right? And if the greatest value lies ahead of lowest value, then we subtract these two value, and it will be our answer. However, this won't work as if we consist mm, like 7, 2, 3, right? So if we take this loop, then the greatest value will be 7 and lowest value will be 2. If we try to subtract this, as the index of 2 is ahead of index 7, so it will simply return 0. However, the correct answer would be or will be 1, is these two can be subtracted. Okay, so at least we have an array, and we go through first and last index at the same time. What we can do is we can subtract this and this, right? We can subtract this and this, and if or we can compare first index with last index. If the value present inside of first index is lower than the value present inside of last index, then we will subtract these two values, right? And suppose we get an answer x. So we'll compare these two value, and if the value present inside of the value present inside of x is greater than the value present inside of y, so mm, but it won't work either. This so I think we need to go through the loop in backward direction, right? And we need to go through its index. And suppose if the value of first is 3, then so let's take random values 7, 8, 4, 2, 1, 2, right? So the correct answer will be 8 minus 3 equals to 5. Sorry. Correct answer would be 7 minus 8 equals to 1, or 2 minus 3 equals to 1, or sorry, my bad. The correct answer will be 1 minus 3 equals to 2. So we are at the last index, and our correct value is 3. Now we'll go to next index, where the current value will be 2. We'll differentiate these two, right? And the value will be 1. We'll go to next index, and we'll differentiate these two values. The difference will be 1. So what we can see is As this number is greater than this number and this number is greater than this number, then we can subtract these two number, or we can simply add this value and it becomes equals to 2. Then we will go to next index. We'll subtract these two, right? And then, as you can see, this number is greater than this, so it doesn't matter to us. And we'll move to next index. If this number is greater than this, it also doesn't matter. And we go come here. As this number is greater than this, and it also doesn't matter. This number is greater than this, then it also doesn't matter, and we will get the value 2. However, and I can't think of any solution. So there doesn't matter. However, the possible difference should be maximum, right? But for that, we need to go through each possible value to find the maximum value. But if we go through each possible value, then we will create time error. So you need to try different approaches. The method I thought worked here, but what if suppose this was 3, this was 2, this was 1. Instead of making this 3, just make this 8. 8 to 1, this is 9, this is 7. Okay. So let's make this 3, make this 2, and make this 1. Okay. So first we are at 8, next we will be at 3. As you can see, 3 is smaller than 8, so we will differentiate this. 8 minus 3, which will be equals to 5. So our current greatest value will be 5. Again, we will come here, and as you can see, 3 is smaller than 2, so we will subtract 8 with 2, which will be equals to 6. And again, we will come at 9, as you can see, 9 is greater than 2. 9 is greater than 2, so it's no use for us. We will come at 7. 7 is greater than 9, sorry, less than 9, so we'll subtract 9 with 7. No, we'll subtract 8 with 7. Value will be 8 with 7, and the value will be 1. And if we subtract 7 with 1, sorry, 8 with 1, if 7 is greater than 1, then the value will be 7. So we get our answer. However, if the greatest, but the greatest answer is 9 minus 1, right? Which is equals to 8. So if we, what we have to do is, we have to go through loop linearly, subtracting the greatest number which we find and compare this number with the next number and next number with another next number. And if we find another number which is greater than previous greatest number, then we have to swap this number with that number and try to subtract again. However, if this was 9 2, then our correct answer would have been 8 minus 2. So we need to create a variable named greatest variable which will store current greatest stock price. Also, we need another variable which is store largest value of stock at our time, and we require our difference variable which will store current difference. Okay, so we have two go through each loop. Z equals to prices dot prices dot size minus 1. I is greater than I is greater than equals to 0. I minus minus. Actually, we can go from minus 2, and we won't require this. We require one variable which will store our greatest stock price, which is 0. We require another variable which will store largest stock value of stock at a time, which will currently be equals to prices last index, which is given by prices dot size minus 1. And what do we need another variable to store difference at a time. What we can do is we can differentiate prices dot sorry we can differentiate largest uh, mm, sorry largest minus prices z, right? This one is prices z, so we'll have current difference. We have to check if this difference is if this difference is greater than our greatest, then we have to swap difference. Sorry, we have to swap greatest with difference. Also, we have to check if largest value is smaller than the value present in prices Z, then we have to swap largest value with prices Z. Hmm. To differentiate, keep here, it should only differentiate of largest value. So after going here, it will differentiate these two, and it is greater than the previous value, so it will restore this value, and it will come here, it will differentiate, as it is smaller, so it won't keep. However, if the largest value is smaller than current value, so largest value will be equals to 9, and it will differentiate this and check if the greatest value is not great, sorry, if the greatest value is greater than the current difference, so it won't swap, and it will subtract this with this. However, instead of 9, if there were to be 1 year, then it will subtract this, and this is difference between 9 and 1 is 8, so it will swap the value and it will return that. I don't know if it will work or not. Okay, so sorry, I wrote Z here. So the whole problem is based upon J, so I can simply swap all I with J. J, here is also J, here is also J. Okay, sorry, didn't declare in this scope. Sorry, I didn't declare J in this scope. Let's try to submit this and hope it will work. Okay, it worked. What is it? Ah, how is this an easy question? Yeah. Okay, let's look at other solution. As we already solved it, so we can look at other question solution too. Look at C++ solution. Let's see. This is Java. Okay, prices profit. I, yeah, is going in ascending way. If prices I is less than by, then by prices. If prices I minus by is greater than our current profit, then profit is short. Okay, I guess that will work too. Yeah, we also did it in the same way. However, we use three different variables in order to always keep track of greatest variable, which is DDR2. This by is used for storing greatest variable. Yeah, or not. Okay, so it's going in ascending way, so it's keeping track of the lowest value. Yeah, if the value is lower, then is keeping the lower value. However, if the value is not lower, then it is obviously greater, so it should be subtracted as is going in ascending way. Yeah, that's what happening. I'm satisfied with my current solution, so I will leave it here. So what I did was actually is we couldn't go through each possible solution. So what I thought is we could always keep track of the greatest value and we could subtract the greatest value with the next value in the loop. And each time we will check whether the previous greatest value is greater than current difference. If it is greater than difference, so it should be our profit, right? However, if it isn't greatest, then we simply won't replace the greatest value with the current difference. And we'll also keep track of the greatest value at that time. If the greatest price of the stock is present in middle part of the array, then the greatest value, or sorry, the greatest price of the stock at that moment will be replaced with the greatest stock price which we just found. And we will try to difference it with other price too. And if that price becomes greater than the current greatest value, then it will simply be swapped. Yeah, that's the logic I used. Yeah. Yeah. That's it for today. Thank you for watching the video. And I will see you tomorrow. Please like, subscribe, and share the video. Goodbye.